So you might be saying to yourself at this point, well, why not just follow the schematic? We've got nothing on the displays here on these controllers. Now, the disconnect is on. I hear the blower motor running, so we've got some sort of power, some sort of control. We're not getting a call at the outdoor unit either. Whatever's going on, we need to start inside, see why we don't have the control voltage. Alright, so looking in here, we got a handful of options, but we got 3 primary transformers, and none of them are tripped on the secondary side. There's some really high-tech wiring there. Right now I'm just doing a visual, seeing if anything stands out to me. Obviously we have our blower motor running, which is ran off of this starter here. That's getting signal. That's a bus, mod 24 is down here. Yep, that's what I expected. We do not have 24 volts here at the controller. Okay, so now we need to figure out why. Now I do know that there is a control fuse. Is it those two? I'm trying to remember. It's been a while since I've worked on this unit. It's a little antiquated, but I remember we had a thing where like the control fuses would blow on occasion. 480 there. That's good. Moving on. I guess we'll go through all these other fuses, because these all branch off in different ways. Let's just start with our basics. That's good. Okay, so we don't have any blown fuses. We know that much. I'm trying to remember though which transformer. I think it's this one here. Feeds 24 up to the controllers up top, which it is not blown. And it pulls power straight from the terminal blocks. So we can confirm real quick, but we know that we've got power there. Alright, so this transformer comes into here. Now this yellow wire, or these 2 red wires, didn't go right back down. But let's first check at these wire nuts and see if we even have 24 this far. I guess transformer went bad. Dropped all the controls out of it. Okay, let me do this. Let me get both hands on this and really make sure I'm getting a proper connection, so I'm not just trying to one-handed diagnose this. We do have 24. Good there. So the one-handed thing just wasn't jiving. Now what that means, we come right back down here and we need to look into why we don't have it making its way back, because we go through a handful of different devices here, but we need to trace out the main 24 as it stands. Ooh, actually, you know what? Hang on a minute. Hang on. Before I get too far ahead of myself, it's coming back to me. I think the 24 for this controller feeds from the 24 outside. So the condensing unit is what is giving my 24 here. Right here. Here we go. Here we go. Here we go. I think maybe not. All right, let's go get the outside opened up now, because I think more than likely our problem is existing there. We have a control fuse or something blown somewhere. So you might be saying to yourself at this point, well, why not just follow the schematic? Problem is, first, there's not much left of the schematic. There's not a schematic for inside. And even if there was, not a whole lot of it matters anymore, because it just ain't the same. Not the same. So that's why I'm just, so that circuit breaker is fine. So we need to see, do we have 24 at R and C right here? We do not. Okay. Now we can trace that out and find out, well, why don't we have 24? Now if I remember correctly, I believe that goes through some of these fuses here. Because this is a resettable fuse. It's not tripped. That's a fuse that when that broke, it's not tripped. So we've got these couple of guys. Do these look okay? Yes. Uh-oh. This fuse is blown, and I'm looking. There's nothing wired in right there. So that tells me that's already been bypassed once before. But this fuse, I'm pretty confident. I'm going to go back and look at the footage I just took. But I believe this fuse that tested good came out of this socket, which is wired in. So let me go check that. I was correct. This is the fuse I just checked, and it came out of there. So the fuse that is functioning is good. We are good to go. So that's not the problem. We can switch back over to volts. So basically we need to trace this through, see where we're losing 24 and why. Okay, so not my phase monitor is not even lit up on the display, so that has me questioning main power. So do we even have power coming into the unit? Let's check that now. Negative. Okay. These have trip indicators. Yes, they have no incoming power. Okay, let me go back to the main power panel and check that there, because I have a feeling that that was supposed to be on and they may have turned it off when it started tripping out. So yeah, well, we should have that issue resolved. So whenever we were walking in, you know, they had turned off the power to the indoor and outdoor, and I only turned the indoor back on and I missed the outdoor breaker. I hear everything clicking now, so we actually have power back. So step one, we got power. All right, we turned on. I have one motor not running. That's one we recently replaced. Now it should have some low ambient controls. So I'm going to give it just a minute to see if it's going to engage it. I would have expected it to turn on by now though. It's not a hot day, but it's warm enough. Doesn't look like that back one is closed or is open either. Okay. Well, that would very likely appear to be part of our problem. We should have that fan online, and we don't. We've got a really hot liquid line. That tells me we got a high condensing temp. So we need that fan to run. So that's likely what's tripping us out, is that fan motor. Now we need to see where that motor runs through, because they all come through right here. I did confirm it's this set of wires coming through from that fan, and if we come in here, they all come through right here. So I'm going to do a quick amp draw to double check. Had no amps here. I'll just pull on that, but I'm pretty confident that is the wire to the motor in question. So that's coming off of this white wire, which is coming off of this relay up top here. Test closed. I want to go to ground. So we showed 237 up there. We'll probably show it here through the winding. I'm going to say that this temperature switch, yeah, I think I got a bad reading. Let me get both hands in here and read back across that temperature switch, but I think that limit is open. So that limit is definitely closed. I'm going to just, for the giggles of it, yeah, still show nothing. So I've got power through to that point. Now, if you're wondering, how these work is once you get below a certain temperature outside, instead of having a typical fan cycling switch, these limits will trip and they'll kill condenser fans to try to maintain head pressure and low ambient. And each one of them is kind of staggered at different temperatures. For example, this one here is set for 75 with a 10-degree offset. That one we were just testing is set for 55 with a 10-degree. And then this third one is set for 85 with a 10 degree. Now we've got a fairly warm day today, so I expect all these fans to be online. Well, this is a tough one. So that motor got changed several weeks ago, and they've had off and on issues for about a week that they've known about, and I'm just now able to get over here. But this wiring was incorrect inside the cabinet here, and it's not completely the tech's fault. It's just this is a really old system. It's very confusing and it's not easy to work on. Regardless, this capacitor is no good, but what added to it was motor we're working on is what was wired to this 15 microfarad. What actually calls for a 10, but this 10 that it's supposed to be wired to is not any good. And you know, yes, capacitors got replaced. I'm not going to go into details of all the stories and what happened and everything else. It's irrelevant. What matters here, we've got it identified. The motor acts like it wants to turn on and run. It just needs a good capacitor so that it can. So we're going to get that taken care of. This one's reading significantly low. I do not have a 10 on my truck because I'm now realizing I moved into a new truck recently and I don't have any truck stock on me. Well, that stinks. Either way, we'll get this capacitor. Before I could even get the capacitor, and I was waiting on to see if somebody was close to me that already had one, I went ahead and verified the windings on the motor. And I'm actually glad that I did, because the reason it was acting funny, I even tried hooking up to one of the 10 microfarads I knew was good, and it just didn't work out. So we're just going to have to replace that motor now. So I got a new one on order. MTT guys, take care of your family, take care of your spouse, your kids. They really need you. We are going into a little bit of a cooler season. Doesn't mean a slower season or a slow season, but it usually gets a little more manageable during this time. So I really encourage you to take this time to try to put that extra time in with your family. In addition, YouTube says you're going to enjoy this video. I really hope you do. Appreciate it, guys.